in this one, you can see that this looks good, that looks good. Oh, I have a difference of 2 squares. So I'm going to immediately go ahead and factor that. All right. Now, again, my idea is to find this common denominator that I can multiply everything by. So what I notice here is I don't want to multiply this times this times this, right? It's kind of like having my 12, 4, and 3. Yes? Like this divides into that. This, did I rewrite that down wrong? I think I did. I did. Sorry about that. You can see that obviously this divides in here, this divides in there, and this divides into itself. So the least common denominator is just going to be x minus 3 times x plus 3. Now, I'm not going to spend the time writing, like multiplying this times times each one of those terms, because a lot of this I can kind of do in my head. Now I'm going to write this kind of in general here. X minus 3 times x plus 3. When I multiply this expression times this fraction, the x minus 3 and the x plus 3s, by the division property, are going to go to 1. So I'm just going to be left with a 4x squared. And multiply this expression times times this fraction, my x plus 3s will divide out to 1. So I'm left with a negative 2x, which is left over a x minus 3. And then that's going to be equal to this x minus 3, this whole fraction times there, the x minus 3's divide out, and I'm left with a 3 times an x plus 3. OK? Now I just need to apply distributive property, right? This is a multi-step equation from Algebra 1. Just go ahead and distribute these. So I have a 4x squared minus a 2x squared plus 6x equals 3x plus 9. Now, I notice I have a quadratic, right? And remember, when we're solving linear equations, our goal is to isolate that variable. But when I recognize I have a quadratic with more than one variable, I can't just like isolate the x. I want to get this quadratic set equal to 0. So I'm going to get all my terms to the same side. This can be simplified to a 2x squared. Subtract that 3x over, so that's going to be a plus 3x. And then that's going to be minus 9. So now I look at this and I say, all right, so I have a quadratic. A is not equal to 1. So I know that if this is factorable, it's going to be factorable into a product of two binomials, where this is going to be a 2x and an x. I see that negative 9 is going to be a, since that's negative, it's going to be a difference with the larger product being positive. So my two numbers that multiply to give me 9 are either 9 and 1 and 3 and 3. And I'm seeing that relationship. That gives you 6x. That gives you negative 3x, which will give you that positive 3x. So therefore, x is equal to 3/2 by using the zero product property, and x is equal to negative 3. Now, here's where that comes into. Remember what I talked about extraneous solutions. We've got to make sure that we verify these solutions, because once we multiplied everything times the LCD, we got a quadratic equation. Yes? So solving a quadratic, we got 2 solutions. But what's important about this, guys, this doesn't look anything like the original problem. Would you guys agree? Right? This is a simplified equation. By solving the simplified equation, we got 2 solutions. However, when I take those 2 solutions and plug them back in, we don't need to plug them into every single x. Basically, what you're looking for is values that are going to be undefined, or a discontinuity. When you plug negative 3 in for x in this denominator, you're going to get 0. Nowhere else where if I plug in 3/2 anywhere in this problem am I going to get 0 in the denominator. So therefore, this is a solution to this equation. That's correct. But it's not a solution to the original equation. Therefore, it's what we call extraneous. OK? And if we were taking a multiple choice question, unless they ask for the extraneous solutions, which they usually don't, if they just ask for the solutions of this equation, the x equals 3/2 would be the only solution on there. OK? All right. I will have you guys go ahead and work on number 3. I'll have you guys